All right, so we are starting. So let's use this question to figure out how to find general solution of PDE means. Then that's what. Okay. So now, in case you remember the last time we met, I introduced you to something that, for instance, if you are to differentiate the function, and you know that in PDE, always the u is a dependent what? Variable. The u is a dependent, not like y you are used to in ODE. But here the u is always a dependent what? Variable. It can be anything though, but what we are basing on is the u. So if I define this, that this function is in terms of x, y, z. If I define that this function is in terms of x, y, z, and I give you, let's say, x squared plus y, and you are to integrate this. Okay, let's make here x. And you are to integrate this. That's going to be, since you are integrating, you integrate both sides, right? So this one is a derivative function. So when you integrate both sides, you will do the what? The derivative. So for that matter, the x will no more come. Here we are going to integrate both sides as respect to what? X. But the function is in terms of what? X, y, z. For that matter, as you take the partial derivative as respect to x, the x will keep on changing while the variable y and the z remain constant. That's the concept. Even though you don't see that we have z here, it can be that the z joint is 0z. Who knows? So you can't ignore. So when you take the integral of both sides, integrating this as respect to ds, integrating as respect to ds, the moment you take the integration, this subscript x will no more come again. I hope it's clear. Alright. So we take the integral of x squared plus y as respect to x. So integrate this, what will you get?
S cube over 3.
S squared over
S cube.
Sorry, s cube over 3 plus
X, Y, X, Y, or Y. X, Y, X, Y.
But don't forget that we are taking the integral of as respect to what? X. By keeping the y and the z constant. Okay? And in integration, constant don't go zero. But rather, the one that you are integrating as respect to now come and attach to the what? To the constant. I hope it's clear. This is no differentiation we are taking that we are going to say this should be zero. We are integrating. So this one is a constant like 2. So as we take the partial derivative as respect to x, if it is 2, I hope you are going to write 2x. So this one will be x, y. But in single, guys, again, but in single calculus, when you take when I say single calculus, I mean OD. In single calculus, that's only one independent variable. This is several independent variables. So in single calculus, when we take the integration, we bring c after that because it's having only one independent variable. But in this case, how many independent variables do we have? 3. And we are taking the integral or the partial derivative, the partial integral as respect to what? X, by holding the y and the z constant. So the constant that we are going to write here is we are no more interested in the c, but rather the c is a function. So if you are using f of g, it will be in terms of y and what? Z. Don't say that the function is not in terms of z. I hope it's clear. Since it's defined here, like I said, it may be 0z. Who knows? So that's how search is going to be, so that we get our function back. Please always clear. All right. So it's the same idea that we used to do the questions there. Yeah, question.
So does it mean that anytime you are asked to find the general solution of a question like this, you are doing it?
Yeah, because this one, everything we have here, they are all derivative functions. They are all derivative functions. This third order, second order, and this one, third order, and this one, third order. So if you want to get a function, then you have to undo the one, the derivative. That's why we use integration there. Please, that always clear. All right. So we now move straight to our first question. Which is s plus minus z. All right. So here we have to look for the general solution. Okay, very good. So, let me say this. Due to our course, vector analysis, we will be doing double integration and triple integration. And when you are doing that double integration and then triple integration, we don't take the derivative from here, but rather we take it from back to forward. So because of that, here we are going to start it from here. Because of double integration and triple integration that we are going to meet in vector analysis. So here, you know that once we integrate as respect to z, the z will vanish. So we are going to get u subscript x, x. You can choose to write this or not. Then you integrate x plus y minus z as respect to z. Let's go for it. So what will be here? We are treating x and y as what? Constant. So when we're treating y and x as constant, this will be xz. It doesn't matter the arrangement, you can even bring dy as dx. Plus yz minus z squared over 2 plus a function of whether g in terms of what? S comma y. I hope it's clear. Alright. Then from here, what we have here is u subscript sx. So if we are undoing the derivatives, we need to go back again by integrating as respect to here, since they are the same, it doesn't matter whether here or it's still the same place. I hope it's clear. Yeah. All that matter is that you just write only one subscript s here. And this is the integral of xz plus yz minus z squared. Okay. So now let's move on. We are integrating as respect to x. So here, what will you get? So here, the focus will only be on the variable what? X. Because if you are to integrate something like 2x, I don't think the focus will be on the 2, but rather the x. So forget about the z there and integrate this. What will you get? S squared z over 2 plus syz, right? Minus sz squared over 2.
The integral of that.
We are integrating this as respect to x. All right. I'll be laying your position there. Let's move on. So, what's going to be the constant?
This are going to be.
Let's say, okay, h. H of y. Z. Now, here, we are integrating as respect to what? X. But the g, the function g is in terms of what? X. So we use the word like it will bounce back to the same thing. It will bounce back to get the same thing since it's in terms of what? X. But let's say okay, when we move to the last one, that one will come in. So this one will repeat itself the same thing as g subscript what? Sorry, g in terms of x and what? Y. Since x is already in terms of the what? The function. Please, I hope that is correct. Okay, sir.
Alex, you were saying that something like this there.
Oh, yeah. So let's make it capital or any G, capital G. Alright. Or you can change it to whether X or so no X already. Letter F. We haven't used F. Okay, you can use F or any of it. I think the capital two will be simple. Okay, thank you. Please always clear. Alright. Wait, this place. I'm saying that we are integrating as respect to X. But this function is already in terms of what? X. So it will bound back to be the same thing. But just that it will not be the same function though. So let's change the small g to big G or any different function like you can use K and the rest. Knowing that the difference between this and this. Alright. Let's move on to the last part because we are still not having you.
The next
Capital G in terms of X and Y. Oh, you repeat everything when you get to this side. Then you write this before you move to this part.
So that integral small
This one.
and in place of that,
Yes. The reason is that here is in terms of X already. Even if you know it's not in terms of, since you're integrating, it will be the same function, but we want to change it so that we see a different function. You can rewrite it though, but don't repeat the same G. Oh yeah.
Or you can link and then two.
Please, I hope I can make it. No.
What he did was I said let g of s be equal to the integral of that, and then he just fixed it over.
Oh, you can also say that let's g of s.
The function we don't.
Please let's wrap up with this so that we can move on. It's not okay. No, it's not. Yeah, that's what we're going to do now. All right. Sorry, your hands. Oh, okay.
And then you were saying that Dr. Lee said that J is equal to something. So after writing the equation, you can write where J integral J of that function is.
So yeah, we are just copying.
Copy.
It's a redeemer. I remember right after you go to I hope now it's clear. Okay, so now let's move on to the last one. As respect to X. So we are integrating again as respect to X. The focus is still on the what? The X variable. So what will happen here? But the 2 will go and multiply the 2 already there. How can you see that? Alright, let's use 6. here to x squared over 2y minus x squared over, and the 2 will multiply there already there. So here, it's going to be the integral of another integral of respect to s plus, please, what is going to be the, let's use k, what is going to be the constant? Y. Alright, so let's analyze. Alright, so now repeat everything up to here. Plus, please let's watch. What's the difference between what we have here and this one? Are they the same? Are they the same? Alright. But yes, we have to change this. You see? So you can change to anything that you want. Let's say M S Y. And I hope you know the reason why we are repeating it. Why the reason? Why the reason why we are repeating the same thing by just changing this? That we are integrating as respect to x, and this is already in terms of what? X. So it bounds back to be the same thing. Alright. Plus, here, let's look at this one carefully. What is the difference between this and this? Is it the same as the bouncing back?
But the operator is not. The function that we are integrating with is not with respect to x.
Alright.
And so we multiply by x.
I think
so you see that one as a constant. Sure. Then multiply it by x.
Sure. So since you are integrating as respect to x, and this function is not in terms of x, so we see the whole this as a constant. So therefore, you attach the x to it.
Okay.
Alright? Very good. Even if you have something like this, and you are integrating as respect to x, what will you get? S squared over 2. Then the whole of this repeats. Please, I hope you are getting what I mean. Let's assume after here you have to go again. After here, I hope you are saying this will be x. Then we change this to, let's say, capital H, Y, Z, plus K, Y, comma Z. That's all. We are done with this.
Wow. I think we will change.
H will remain the same.
Where you are? Yeah. Sure. Then we are treating that as a constant. It remains the same. Alright. What I'm saying is that, what if here is, what if we also have another x here? That is the fourth one, order. That means that when you reach this part, you go again. So it will be like you go and integrate something like this again. Let me make that place H, because we can't solve all questions in this world. So if you are integrating this, what would that be?
S squared over 2.
S squared over 2.
H into bracket Z over comma Y.
Please, I always clear. Alright, so since we are going to treat this as a constant, we integrate this. So this will be S squared over 2, then the HS Y. That is all. Please, I always clear. Alright, so I think we can go and continue the rest.
So the second.
Which one? Second one. Please help I can take it. Okay. This question they are from the tutorial sense. Okay, so here we move straight to the point. Sin S Y as respect to x. Okay, so we are integrating. And we are integrating a transcendental function. And anytime we integrate a transcendental function, going to an integral of 2x dx, since it's a transcendental function, this constant will be 1 over. Just shorten. Now you copy the whole thing again. That's all. The same thing to this. So, since we are integrating as respect to x, which one is the constant? The y. So it should be 1 over the y. You see that? So 1 over the y. Then what will happen? We copy the whole thing. Then we integrate the y. It's like chain rule. So we copy the whole thing. After this, we copy the whole thing. And then plus 1. Then we multiply by what? The derivative of the what? Of the inside, which is what? Sy. In this case, we are treating y as what? Constant. So when we integrate this, what are we going to get? Okay. Since we are treating y as constant, that place is going to be like somebody saying y. Y here to be left with the constant, which is y. So we are going to get y times 1 over y sine of x y. This will cancel this, and that is all. Then you go again.
The cost.
Go through that one.
Hey,
No,
I'm learning something.
let's take the integration again.
I'm learning something.
When you go through,
We didn't integrate the whole thing. Yeah.
people that said you didn't say that.
No. Okay, so this will be 1 over y. Then when you integrate this, you get what?
Why is it
Negative
1 over y?
cos, right?
Wait, why is it 1 over y? I didn't get that place. Sorry, okay.
Now it's 1. You know that here when you integrate sine x, you get what? Negative cos what? X. Cos x. But a constant, if a constant is there,
Is it negative cos of cos?
it's negative.
Wait. Negative cos.
See, if you integrate this, you get negative cos x.
I remember you integrate the whole thing first. So I will integrate the whole thing first.
You don't need to write that plus 1.
No, I know the negative.
When you integrate this, you get this.
Yes.
Now, if you have a constant in general a, it will just be 1 over the a. Any transcendental function, that's how it behaves. You mean, so that's it. So this one we are going to get negative cos xy. Then we differentiate the inside. Then we get what? Oh, so that's all. That's all. So we get u subscript x is equal to this. Yeah, plus. And the constant will be, the function is in terms of what? See, yeah, you see this one is not like this. This one is not like this. So what you see is what supposed to be there. So it means that in terms of what? The independent variable is only 2, x and y. Since it's not defined here for you that x, y is, so x and y. So this one will be the function in terms of y. Then you go with the integration again. U is equal to the integral of. This is a constant. You know we are integrating as respect to what? X. So that means that this is a constant. So we can even bring it out. Agree?
Yes.
you are integrating as respect to x. So the whole of this is a constant. So we can bring it out. So that below is called xy plus fy. I hope you agree with me. So here we can move on to negative 1 over y. Integrate this the same way. Okay. So what will happen? When you integrate the whole thing, you get what? This getting negative 1.
Positive sign.
So sin xy. Then you differentiate the inside. Then it will be 1 over y.
With respect to
So you are doing as respect to x. So the y is a constant. So this one is there already. Is that what you agree with me? This one is there already. But you don't have to forget that this is affecting the whole of the.
No, you know.
Oh, you know the whole thing. Yeah, this one, let's maintain it. Let's maintain this one.
Leave the integral sum of f of y.
Okay, so that I can integrate 10 by 10. Yeah. Every integrated 10 by 10. Okay, so here when you're integrating this one come out 1 over y. You are okay with this sin xy. Okay, let's move on. Plus the integral of plus g of y again. Oh, but here you're integrating. Okay, we have a. Okay, so what will happen to this? Negative 1 over y squared sine of xy plus x f of f of y. So that's it. The rest is double and